I see a connection, but I don't. I think I must stop streaming and start again. Let's try. 1, 2, 3, 4, 5. I think my internet connection is back now. Yeah, I see myself on YouTube now. Not yet on Twitch, but maybe it will be fixed. Okay, something is wrong with Twitch. Sorry for that. Maybe I kicked my internet connection cable or something, because everything worked correctly on my laptop, but not in my PC connected by cable. I think I will refresh this chat. Sorry for issues. So I coded for like a minute or two without knowing that the stream is off. Buenos dias. Hey. I moved some stuff to the recursive function, and I want to run it once for every starting with 3, then 2. I want to run it for everything from 1 to n-2. Recursive function rec and I. Remove that. When something is true here, then I want to also iterate through the everything in the neighborhood. From max of i-2 and 1 to min of my m-2 and i+2. Also run recursive function with j requirement. First of all with a 3. Maybe. No anything. Iterate with requirement with 3 and then up to rec. I think this should prioritize requirement 3 and only then move to 2. What about this? The complexity should be limited by n. I hope. Let's see how does it work on samples. It does. So let's submit. And still there is an issue with Twitch, or is it? Yep. I don't understand why. DCPP submit. I lost some time here. I just hope this is correct. This is not correct, and that's bad. I could now, I guess, see the test, but I don't want to cheat. So maybe maybe I need to also do something with those numbers. First thing is whether this version is equivalent to my previous version that was quadratic. Let's try that. I have DCPP and D2CPP. Here let's roll back to a version that it was quadratic. Here it is. I will stress test it against each other. Copy templates to generator CPP. Take seed as an argument. choose the first argument as a seed, create a function that will return a random value between a and b. And what do we do here? Let's see the input description and things. M is the number of types. Let it be up to, I don't know, 8. N times repeat, printing a random value from 1 to the number of types, and print a new line. Let's try it. Looks like valid tests. Now I need a script that will start with seed 1. This should just print seed. Now instead I want to run generator with this seed and save to a file, and compare D, run on that, and D2, run on that, or break. It will break if there is a difference. There is. That was quick. Let's copy this test to hack. Now let's try finding a smaller test. Here it is. For this test, D says 1, D2 says 0. The correct answer should be 1. So D2 was incorrect. Why is it incorrect? D2 was the one with recursive stuff. So after the counts, here I will have for this test counts 1, 1, 2. It should understand that I increase answer by 1. Some 0 is false, it shouldn't be. Let's print I and count good. D2 run on int. Oh, it's there is some error out of bound with going out of boundaries. Is this test valid? It looks like. Okay. GDB D2 run on int and BT. Line 43. Here count of J. How is it possible? Oh, I pass here in incorrect order. I rec. Quit, yes. Let's remove this printing debug and compare it now. Looks fine. Let's get back to bigger values. Nope, it's incorrect. For this test, let's copy it to hack and let's try to find a smaller test. 10, 4. Looks okay. I will change it to 5. Here we go. What is the array? We have 2 1s, then 2 2s. I can just print the array. For x in count, CERR x space. Zero, 2, 2, 3, 3. Program D says 2. I think correct version is 3. So the brute force is incorrect. How? Why is it incorrect? Let's see what happens here. If take. Maybe my fast version is already correct, but I want to investigate what happens. I first take this 3, then this 3. This is incorrect. I don't... Why 0? It's not so important. I don't understand the question. 0 where? Like this is count of numbers equal to 0. Doesn't matter. Okay, after taking this 3, I shouldn't take this 3, because still it's possible. No, I understand. After finding some 3 consecutive values where there are 2 non-divisible by 3, I should break. And first of all, I should try finding 3 consecutive. Twitch stream is not working. I don't know what to do about it, sorry. I guess we are on YouTube only. So if this if rec is 2, break. Let's remove that part then. In D2 as well. And run the comparison. Do I need the same thing in D2? I don't think so. Let's submit D2, which is the faster version. Yep. At least now I know that my 2 versions, quadratic one and linear one, are equivalent because they pass tests. I can also try increasing the values here. Wrong answer on test 4. Awesome. I hope the problem D gets accepted. I also hope so. Another bad thing now is that my chat doesn't work, so I don't see what happens. Oh, the question was why I don't print return 0, because, oh, I have a counter test. Because it isn't necessary in C++. 0 is the default value. The default return, it's returned by default. Okay, we have some counter test. Let's copy it to hack. Let's see what is the difference. In D2 I printed counts. Zero, 2, 2, 2, 2, 2, 2. And D was incorrect here. It says 3. I guess in D we first check this triple and then the next triple, and that's bad. So maybe it's better to check this one again. In D2 it worked. I would say magically. What about this test? Hack 2. I want to create a test such that the counts will be 3, 2, 2, 2, 2, like that. Because now I only have a counter test against DCPP, not against D2. I'll rewrite my previous comment on Twitch. Yeah, I will answer that later. So the bad thing is my approach can be completely incorrect. Maybe I should abandon this problem now, while I still have time to think about other problems. But it has many accepted, so it can be very hard. Maybe just it's some dynamic programming that I miss. Okay, I can write exponential solution, so a brute force that will try everything. Let's just copy the logic from here, so counts, and then run recursive solution on the vector of counts. And print the answer. Recursive solution on vector of counts and answer so far. No, it's not necessary. Let answer be, so here initials, get sum. It will sum elements in count. Count is not global. This returns the sum of elements in the given vector. The initial sum will be counted here. Init sum is get sum of count. After I do anything, I will do here answer is max answer and init sum minus get sum of current count divided by 3. So this is the difference that is taken. Set of vector of int done. If done count, if this is available there, return. Done insert count. This can be done slightly faster, but whatever. Now iterate from 1 to m minus 2 if count of I, if minimum of those, count of I plus 1, count of I plus 2 is greater or equal 1, then consider decreasing. So for j in I plus 1, I plus 2, minus minus count of j, recursive on count, and then change it back, plus plus. Also for everything, if this is at least 3, count of I minus equal 3, recursive of count, count back plus equal 3. I think this works in exponential time and tries all the possibilities. Okay, and now D2 I want to compare with expo, an exponential solution. I should remove this count. Where was it? Here. Is Dfs algorithm based? Yes, a little bit. Mine is also scheduled for upcoming week. Can you tell how's your interview? We will talk about that later. Okay, we have a counter test. Was it the same as the one I saved? Yes. So here this was incorrect. This was a vector of 2's. Copy int to hack. Now d run. Oh, because I didn't save it. I wanted to compare with expo. I compared with my previous solution, and again remove that thing. D2. Copy this to make it a hack, but in the meantime I will try to find a smaller counter test to make it easier to analyze. Doesn't look like there is anything wrong here. Maybe now with slightly bigger values. And I can start analyzing the hacky test. D2 print counts. Permission denied because I recompiled. D2 on hack. 5331. Expo says 4. Because I should take this 3. I should take this 3 times. And then take this 3. So maybe I sometimes have to take 3 consecutive values if 2 of them are divisible. I will try to add it then. 3 to 1. Here from 3 to this. But if requirement is 1, then one of them must be equal to, and here count good is greater than 1, or the sum count of I modulo 3 plus count of I plus 1 modulo 3 plus, let's make it TMP, the sum of values modulo 3. Or TMP is 2. D2 on hack. Now it's correct, but maybe I messed up the correctness on some other tests. I should increase the values here. Yeah, doesn't work. That's bad. 4, 3, 2, 3, 2. Expon int is 4. Why? What is a correct approach here? We can take these 2 as wholes and then use these 2 multiple times. So maybe values modulo 3 matter more than I thought. I should prioritize this triple more. I'm wasting a lot of time on this problem. That's bad. Maybe requirement will be the sum of values modulo 3. if that makes any sense. Copy D2CPP, memo D2CPP. Let's change that to from requirement 6 to 2. So now requirement is not the number of non-divisible numbers, but the sum modulo modulo 2. Count good plus equal count of j modulo 3. Something like that. D2 on this is correct. D2 on in 2, in 3. On samples it works, and here it doesn't on this test. D2 on int. This here I printed 2, while the correct answer is 3. What should be done? We can take... How to get 3 here? I can take this triple, and this 3 as a whole. After I take this one, so what will my algorithm take instead? It will prioritize the sum of values modulo 3, and here we have sum 3, while this is the same and this is the same. After this move, everything is wasted. I can't get an optimal score anymore. So my approach is completely wrong. I think I have still time to try a problem F instead. So I will move to F, because my greedy approach is apparently a bad idea. So let's analyze F instead. Would you have actually given the question so much time if you are participating in the contest itself? It's a bit random, but yeah, I don't see a solution. I wasted of course I wasted some time on explaining stuff and talking out loud, or on my internet connection issue. But the main issue is that I don't know how to solve this problem. Okay, problem F. Consider Dfs algorithm which traverses a tree and enumerates them in order of visiting. Only the first visit of each vertex counts. Formally, you can describe this function using the following pseudocode. Mark as visited for 2 in neighbors of V, increasing order. If not visited, then you are given a weighted tree, the vertices of which are enumerated with integers 1 through n using the algorithm described above. A leaf is a vertex. Do we start, by the way, in vertex 1? Yes, we do. A leaf is a vertex of the tree which is connected with only one other vertex. Possibly also a root, apparently. If the tree given to you, the vertex 1 is not a leaf, okay, so it's not. The distance between 2 vertices in the tree is the sum of weights of edges on the simple path between them. You have to answer Q queries of the following type. Given integers v, l, r, find the shortest distance from vertex v to one of the leaves with indices from L to R inclusive. Find the shortest distance from vertex V to one of the leaves. And the important thing will be that this indices in some interval represents something like a subtree. Where's my sketchpad? It's here. when we have some tree and we traverse it with DFS, leaves will be numbered from left to right, roughly. Here we would get 1, 2, 3, 4, 5, 6, 7. Let's say here it's something else. 8, 9, 10, 11, 12. I'm just numbering leaves. There are some other vertices that will be in between, so it will be in fact something like 3, 4 here, 5, 6, but still leaves are increasing from left to right. Their numbers are increasing. They ask us about the maximum distance from some vertex to some interval of leaves. For example, it will be from this leaf up to maybe this leaf. Yep. And either the vertex V, we can imagine a path maybe between this first leaf and the last leaf, and say that on this path, let's for now maximize the drawing, for on this path, this one, we want to know where does V, if V is here, then we want to know where does V enter this path. What is a vertex closest to the path between the two most distant leaves? Not two most distant, but the first and the last leaf that we care about. Does it make any sense? Because now every leaf, no, but V can also be like here. And I have half an hour to solve this problem. Yep, 27 minutes. Only the furthest leaf is interesting for us. Maybe we will build some segment tree over the leaves to be able to answer something about a segment. Let's also remember that we can solve the problem offline, what means first read all the queries and only them put them on a tree and do something smart simultaneously for all the queries. What can we do? Now we can change the color. If V is here in this case, I would like to know in this direction what is the furthermost leaf among those ones. So maybe just in this segment of leaves which one is the deepest. The harder query is this one. It means among leaves in this interval, which one has the biggest value of distance to this LCA with our vertex V, and then this value. So we generally the distance between two things is depth of one thing plus depth of second thing. So the depth of A plus depth of B minus 2 times depth of LCA. Because let's remember that here maybe some more vertices are here, and if I say depth of this one plus depth of this one, then I unnecessarily counted this to the distance. I want to maximize this thing. And depth of A I already know, this will be that vertex V. I want to just maximize this. Maybe if I look in this direction, I want to know for every prefix. Maybe for every power of 2, something like KMR algorithm, where we do some preprocessing for every power of 2, for every interval that has size that is a power of 2. Are you still in college? Where do you live? In Warsaw. No, I'm not in college. Why are we trying to find the maximum distance where the problem asks for the minimum distance? Does it? Oh yes, it does. Find the shortest distance. That might change everything. Or will it? Thank you for saying that. On one hand, I didn't want help from viewers. On the other hand, maybe I would not misread that if I didn't do a stream, because I kind of hurry through the statement. Do we have samples explanation? Okay, doesn't matter. It's too small to give us something, but yeah, we are looking for the closest one. So here it will be, in this case, we are looking for the closest one in this direction, then also closest one here. Maybe I'm thinking a lot about this KMR algorithm. What if V is in some different place? Like maybe this 7 has 2 more children and these are leaves, and V is here. Then what happens? Then V is like inside this path almost. He'd like to show support, whatever, but yeah. If V is inside everything, then it's easy to take minimum depth of a leaf inside a subtree. This will be a subtree in that case, and I can know the minimum depth of a leaf. That's not an issue. What will remain is asking about best score in this direction, closest vertex, closest leaf. And even before this vertex V will get to the red path, here there might be more vertices with subtrees. And it becomes a bit harder to care about that, or does it? What about centroids? So now I'm thinking about the centroid decomposition. What this would do. Hello, Jatin. Like centroid decomposition, or maybe some other decomposition of leaves into intervals. I think centroid decomposition might make sense. If we have a centroid and some subtrees, then some of them can be outside of the interval of leaves we are interested in. Here maybe this would be a centroid. Then we have one subtree here, this one. So it contains some leaves in the interval and some outside the interval. But if we have some segment tree built over those leaves, we can quickly say in this direction what is the closest leaf in some interval of values. I think this is easy to do, maybe complicated to implement. And what happens if V is here? I will just answer each of those subtrees about it. Closest one. Okay, I will generally ask about the distance from this vertex to the closest leaf that is in some interval, and then I will say that I care about this path from V to this vertex, plus that closest path to a leaf in some leaf. Okay, I think that is a correct solution. Who knows, is he going to save this stream? All my streams are later available in YouTube, so you don't have to worry about that. Okay, Genie. And now we are implementing FCPP. How much time do I have? 15 minutes. That should be enough. Do I want to do it offline? By the way, how does it look like? Yeah, I must do F and still my result won't be very good. Read N and Q. I'm still not sure if I want to do it offline. Edges. For everything, stuff is numbered from 1 to n. Yep. For b2 up to n, read the parent. Do I want to root it in 1? What happens next? Yeah, I don't care what is given exactly in the input, I just want to store edges. Edges of A push back B, edges of B push back C. Actually, we also have length, right? Yep. Cost C. So A and C. Read both. Sure, Alexa, you can watch it offline or now. M place back BC, edges of B, M place back AC. Next will be the maximum possible n. This stores edges. Dfs of 1. I need an array for forbidden vertices that are already some centroids. Now, Dfs. What do? We need a Dfs that will compute subtree sizes. So int subtree of next, Dfs of subtree. For parent, for edges of A, B is edge first. If forbidden of B, or B is parent, then continue, otherwise do something. Here subtree of A is 1, Dfs subtree of B, subtree of A plus equals subtree of B. I think this way we computed subtree sizes. So this will be Dfs centroid. Dfs subtree of A with parent -1. Here with parent A, int parent. In edges of A, what is wrong? Here it should be of size max. How many programming languages do you know? C++, Python, and Java. And only C++ I know, let's say, well. Now, total size is subtree of A. I want to go down, so while true, for edge in edges of A, B is edge first. If forbidden of B or B is parent, then continue. If subtree of B greater equal total size divided by 2, then A is B and break. Moved is false. Here moved is true. If I didn't move, if not moved, then break. This should go down as long as some child has subtree that it has size at least total size divided by 2. And this way now A is a centroid. And I will do something like forbidden of A is true for edges, and edges of A, B is edge first. If not forbidden of B, then Dfs centroid of B. Okay, this is centroid decomposition. Are you using arrow keys to move cursor? Yes, I use it too, but I also use mouse. I don't have parent here. and that should be it. I can take the first sample and is it drawn? And 5, yeah, I can see what centroids there are. F on infinite loop. So something is wrong. Here I only want to go to children, so if subtree of B smaller than subtree of A, and that. This will be moving to a child. Why was this printed multiple times? A is that. It shouldn't be so. A, B. From 3 I move to 1, so 3 is the first centroid. From 2 I also move to 1. What? Oh, I have my debug, by the way. I forgot that I can use it. I tried not to, so I wasted some time. This is my like template debug thing. Remember A here. Okay. When I started from 1, some strange thing happens. Why do I run something multiple times? I mark this. I move through edges. That's strange. So from 1 I found a subtree 3. From 3, 1 of I move to 1, 4 and 5. Then from 1 this. Okay, it is not incorrect. I think everything should be printed here only once. So if I do this now, and also I can remove that, whatever. Well, everything should be printed once. Yes, it's true. Now, what are queries? Every query is of form vertex and length, like the interval. Struct query. It has ID, some vertex v, l and r. Read of given ID. D is ID and read VLR. Here I will have answer of size max. At the end I'm going to print, so I'm going for an offline solution. Here print answer of I. First initialize that with infinities. Answer of I plus equal, not plus equal, is equal to just infinity. Infinity is 10 to the 18. How do you increase typing speed? You can practice it. And I want to here pass vector of q queries. First initialize that by here saying q query read of I, and pass queries. Okay, I don't use that. Here I will pass something. And I need to do something. Is not only subtree, but I also need from this centroid, I need Dfs, like what, depth of A. Void Dfs depth int A, and again it will be similar to the previous one, so let's copy paste. So this is Dfs depth, and instead of subtree sizes, if forbidden, okay, and I will say, where is it? Here, depth of A is 0. Before running Dfs depth of that, depth of B is depth of A plus edge second. Depth not declared. Yes, it is not. It's long. I have 4 minutes left, so I don't think I will solve it in time. That's a pity. -1. After that, I iterate over all the queries. And what I need. There is some L, R, and there is query L, query R, and in this interval I need to do something. Let's create globally. This is a big power of 2, like that. 3 of 2 times base. It will be a 3 of minimum, so I must initialize that with plus infinities. And now for every query, I want to take TMP will be the best depth from A, best depth from A, best depth of leaf in interval query L, query R. So in this depth, I will say, well, isLeaf is true. If I move to some child, then isLeaf is false. Here apparently it's a leaf. Or no, it must be leaf of the whole tree. One moment. Did they guarantee the vertex 1 is not a leaf? Okay, I don't need that. Instead, if edges of a size is 1, so if it's a leaf in the whole tree, then 3 of base plus a is what? Is depth of a. Also, just update the whole thing in the tree. 3 of I is minimum of 3 of 2 times I, 3 of 2 times I plus 1. Makes sense? Yeah, I think so. So in tree we have minimum over leaves. Low is base plus query of L. High is, and I have 1 minute left, so as I said, I will not finish in time, but I will try to finish in like 5 minutes maybe. TMP is 3 of low. If low different, then maybe just it's minimum of 3 of low, 3 of high. Yeah, I'm out of time. Well, low smaller than high minus 1, if low like that, TMP is mu of itself and 3 of low plus 1. Similar thing for high, if high is a right child. Then compare with the left child. Now TMP is the best depth, so answer of query ID is minimum of itself and TMP plus depth of query V. After that, let's say that Dfs of depth gathered all the leaves pushback A. After I'm done here, for everything in leaves 3 of base plus x is infinity, and update the path to the root. And clear the leaves. So now the tree should be filled with plus infinities. Here pass the queries, but we shouldn't pass queries that aren't inside that tree. Vertex V should be inside. I will say it like that. Here I go through some vertices. Let's say Dfs of subtree. I will create an array is our vertex here. In Dfs of subtree, here pushback A, and I will create an array as well to quickly say whether something is here. Here will be to clear stuff. I will do for everything in here is here x is false and here clear. But first new queries. For every query in queries, if not is here of QV, then if is here, then new queries pushback query, and queries is new queries. Let's try it. Just infinities. Answer of I is infinity, read query, and maybe queries pushback query. Infinite loop. In something related to queries, I guess. Maybe I don't update the tree correctly in some place. Do I know Tomek Czajka? Yes, I know him. When did you start competitive programming? 7 years ago in high school. Can you make a video in future your whole journey of programming? Maybe. Maybe I will. Something related to queries doesn't work. Here I iterate. Okay, I forgot to divide by 2. Divide by 2. 3, 0, 0, 13. Looks okay. Here it should be millions. Looks okay. And here is a long test. Let's compile without the debug. Does it match? 8, 8, 9, 16. Yes, it does. Let's submit. I'm a bit worried about the running time. The constant factor should be quite big. I run multiple DFSs and it's n log n anyway because of centroid decomposition. Have you participated in competitions like Code Jam? Yep, and indeed I was second this year. Regarding the typing speed, it doesn't matter much. Rohit said, I had my Google on-site interview on Friday, and thanks to one of your videos, where you proved the algo is indeed 26 times n, and not n times 26 square, helped me to prove something similar. Thanks a lot. I'm very glad my videos were helpful for you. It's awesome to hear that. Hey, will you make more lecture streams? They are awesome. Yes, I will. Just it requires time for me to prepare it. And I got time limit exceeded indeed, unfortunately. I said that I'm worried about the running time. I think just the constraints here should be slightly slower. I will first of all generate a max test. How to do it? I can create a line easily. Gen2 CPP n is from the arguments, q as well. Let's say n and q are equal. And now, also maybe I have a mistake in where I find a centroid decomposition. I will check that later. But first, let's see how fast it is for a max test. For everything from 2 to n, just say that the parent is the previous vertex, I minus 1, and the weight with 5000, whatever for now. Q queries. Assuming that I is equal, that q is equal n, I can say that it will be v l r. Here v is just I, l is random vertex, r is random vertex. If l greater than r, then swap. Gen2 seed and nq looks okay. F. Can this be infinity? Yes, it can. What happens if I print infinity? It is guaranteed that there is at least one leaf with index x. Okay, but doesn't matter for me. Instead I will print infinity. Now f is here. Gen2 with this seed and 10,000 vertices. Let's save to file big and measure the time. Something is wrong. Oh, it should be Gen2. Time f big. It was fast. Now 500,000. Limit. I must increase the stack size, and it's slow. 2 seconds. On my computer on a random test. Let's also try that was a line, a tree that is a bamboo or a line. Now let's try a star. it's the same time. The question is whether this could give me time limit exceeded. I think so, my computer is quite fast. So let's try. I will first check if I find a centroid correctly. Here I should go to a child if its subtree size is still at least the total size divided by 2. Do I have to care about the ceiling, or should I round this up? I don't think I have to. And queries will be passed to only one thing. Let's make things slightly faster by doing what? Here I can say swap. This is faster, I think it's constant time. Where I iterate over edges, I can use a reference. Here, let's also do it this way. Oh, I have log square because of this part. Maybe this should be improved. But the DFSs will also be quite slow. I didn't improve it even a little bit. What if I remove this part? I want to see which part is slow. It became 0.7. Yeah, I should improve this part. Maybe BIT would be better. So binary index tree. I don't think we can use it here. I just joined. Where are you using centroid decomposition in this? Well, this is my solution. Why don't you use auto, const auto? Like, why should I? Query is not. I don't write down query slower than auto, and this way I see that this will be a query. Can't you just Euler turp plus sec3? I don't know. Maybe there are different solutions. Bitset is the answer. Yes, I think I should use bitset here to get 30 times faster solution. Is C outdated for competitive programming? Yeah, more competitions use C++. So I would say yes, C is outdated. What can I do here? Don't really have an idea. Maybe, what about this? If here size smaller equal 15, then here clear and break, would this be faster? Not break, return. Maybe I should do something faster for smaller trees. No, it didn't change anything. Do you stream daily on competitive programming? No. About weekly. So far I'm doing Tuesdays regularly. I will try to keep it that way, or at least make some fixed schedule. I believe the intended solution here is n log n. I didn't notice that with centroid decomposition plus this I have log square. What should I do? Maybe I should use the fact that usually vertices of a part of centroid will be only in some interval, and I should construct a smaller tree. The complexity will not change though. That's bad. By the way, let's see what place I would have. People managed to solve G as well. I would be very far in the leaderboard. I don't even see myself. Friends standings. 3 for 1. That's a bad contest for me. Well, maybe I would solve F given a bit more time, but we'll see that in a moment. I wonder what is a solution for D. I will check that soon. What did I have? Yeah, I had the wrong answer because my solution was completely wrong. So I did fine until E. Do you consider difficulty of these E and F questions more than code jam? I will say that after I solve it, but looking at times of people here, E and F are easier than hard code jam problems. Can you explain your solution from algorithmic point of view? What does algorithmic point of view mean? I said in some moment what I do. I do centroid decomposition, and for every query that I have, I check what is the distance from the current centroid, this one, to the closest leaf in my interval from L to R, and after that, and I consider the answer of this query to be the distance from V to the centroid plus that distance. Possibly incorrectly, I say that leaf would be here, and I count distance from V to the centroid and then back here, but it doesn't matter because later I will go inside this part of a tree and find a new centroid, and I will update the answer. My approach is correct for finding the closest vertex, but not the furthermost vertex. And the complexity is, I thought it's q plus n times log n, because centroids are n log n in general, but I forgot that inside I also have answering here, where was it? Yeah, for every query I answer about the minimum distance. Your teammate MNBVMar is on 4th. Yeah, he's not usually my teammate. Marek Som is often, and Radeusz. Marek Sokolowski is my teammate in Hashcode currently. But usually in ACM ICPC he was in a team with Świstak and Marcin Smu. So binary index tree is able to only do prefixes, so this is not enough for me. I could also use KMR algorithm to only know answers for all the intervals that have size of power of 2, and then this part would be constant. But creating this would be linear. In the editorial, the expected runtime is indeed n log n plus q log n. So my complexity is not optimal. So your algorithm should be good, right? Well, I think it's correct, but my complexity is log square. I have n log n because of centroid decomposition, and here I have extra times log. Can I improve it in any way? I don't see how. Without it, it should be fine. If I had, after commenting this part, making if 0 here. My running time decreases to 0.7. I think that should pass. I can also now maybe see my results for tests. Is it something particular? Everything is connected with a 1, so it's a star. Here I have times 1.3, 1.7. 1.7 was already for for what? 400,000. So for a star, let's change that to a star. No, did I do something here? Yeah. This should be 2 seconds. And is it any slower if I change something here? Maybe do 1n. No, it isn't slower. What about changing this to 1? Doesn't change either. By the way, is big 500,000? Is it max test? Yes, it is. Right? 500,000. I can also try custom invocation to see how far away I'm from getting accepted. So I will just copy my my solution, and here write n is q is for now 100,000. Here a is 1, c is 5,000. Queries, is it everything? No, queries. Queries read of I. V is equal to id. L is 1 plus rand modulo n. R is 1 plus rand modulo n. Let's make that uppercase n. If L greater than R, swap. And don't read. Run. This should be fast. And n not declared, because here I want to do n is smaller n and n is global. I want to do it this way because I wasn't sure if I can pass so big test here. What is the size of test big? It's 16 megabytes, so it exceeds allowed here 256 kilobytes. This is why I have to modify code and just instead of reading say what are n and q. Does it work? I wonder if it's really running or maybe I'm waiting here. Does it work locally? Try CPP. Oh, it's infinite loop. I guess it's waiting for something. Time limit exceeded 10 seconds. Yeah, so I messed something up. A is 1, C is 5,000, looks okay. And then Q are that. Let's for now change this to 1,000. No, it worked. 10,000. It worked as well, but why is it so slow? 100,000. What is wrong here? 50,000, 10,000, 20. It looks quadratic. Why? I generated in a similar way a test with Gen2, the file big. I don't understand why now this would be quadratic. Everything is connected with vertex 1. I can create, what can I create? Long Z. And in DFS Centroid, I will say Z plus equal queries size and Z plus equal here size. At the end, let's print Z. This way I will know how many operations roughly I do. And now 40,000. Yes, it's quadratic. Everything is connected with one. I understand now. Queries. When I have a star, so I messed up the complexity. When I have a star, where's my pen? When I have Q queries and I have a star, I pass those queries to each children, and possibly complexity will be n times Q. I need to pass it smarter. So here the issue is I can't pass all the queries. I need to pass only some of them, otherwise it's quadratic. What to do about that? Everything in my last DFS, let's say DFS depth, should have a group. Okay. Int group of NUCs. DFS of depth. I will say if parent is -1, then group of B is B, otherwise group of B is group of A. Now every vertex knows to which group it belongs. I can remove this part. Because I will pass only queries that are indeed in this part. Then here we split queries. Split queries for Q in queries. If QV is not in what? Is not the centroid, then his queries of group of QV, QV pushback Q. And now queries are splitted. Here I should only pass his queries of group of B. The thing is, when I run this Centroid, something can mess up or not. Let's do it like that. Auto whatever is group of B, group of B clear, and pass just with whatever. Not, it should be his queries. Now vector of Q, his queries of nugs. This should be declared after creating struct Q. Now it's faster. Let's remove this, or it can stay. Let's try with bigger N and Q. Yeah, it's fast. Let's instead read N and Q. This should be read. Scanf N and Q. Now in function read, where is read? We read everything. Try big, time try big. 2 seconds, please. Yep. The number of operations was roughly 10 million. I think I fixed the complexity. I mean, it's not quadratic at least. But still the constant factor can be too big. In the meantime, I will take a look at the tutorial for D. Okay, it is dynamic programming. First thing to note is that one can try solving this problem with different greedy approaches, but authors don't know any correct greedy. I don't know either. To solve this problem, note that you can always replace 3 triples of type dat with triples. What? Oh, yes. We can use at most 2. We should use at most 2 triples of 3 consecutive numbers. That was an easy problem, after all. And F is accepted. Maybe I would solve that during a contest, maybe not. And with D, I just... the dynamic programming was quite easy. Let me absolve that. Just remove everything. So we do dynamic programming, but we say every 3 consecutive numbers should be taken at most 2 times. If we take 3 times, then we can also say just take 3 triples as a whole. Can solve the noob. Well, it happens. And the problem F was accepted with log square, which is fine. Now what happens here? I need dp of that size, dp nax 3. Can you please explain the dp approach for problem D? While solving, I will explain that. dp of xab means that we considered everything up to prefix I, so now we consider position x, and we used what? We can use, and let's say a of a minus 2 of x minus 2. So this is value a x minus 2, remaining value. The remaining value at x minus 2 is a, and at x minus 1 is b. We need at most 2 there. If value at x minus 1 is 5, we will still treat it as 2. Because the lemma is 3 consecutive numbers at some positions we take together at most 2 times. Now, is this correct? I can make it slightly bigger. Let's make it 5. So dp of 0, 0 is 0. Now for every new thing, for a from 0 to 4, for b, for here how many triples consecutive triples we take, which is first mi is dp of I a b. If mi is smaller than 0, what do? Maximize. So by default we treat everything as minus infinity. Minus infinity. If this is smaller than 0, then continue. Otherwise, iterate over the number of times, the number x with the number c, the number of times we use a triple a minus 2, a minus 1, I. Sorry, I minus 2, I minus 1, I. Iterate with c from 0 to minimum of a, b, count of I, we can't use more than that, and 2 because we use at most 2 times. That was c. I wanted to write c smaller equal, and here dp of new a will be b minus c, new b will be count of I minus c minimized with 4. This is how many things will stay here. And dp of a plus 1, a2, b2 is max of itself and mi plus c plus something else. How many times do I want to use a triple here? Let's instead it's not so easy. And at the end, what do I do? Answer is 0. Iterate with A and B. vPlanet have some videos on DP. That's true. B small equal 4 plus B. Answer is max of itself and DP of m plus 1 A and B. Print answer. Finally, what do I do here? Do I know what to put here? It's like the remaining value divided by 3. Maybe I should also say remaining stuff at this position. Unfortunately, the constant factor now will be big. Up to what, 4? Yeah, 4. Rem is 4, so here count, not count, but rem. Rem is the remaining number of things at this position I. Here minimum of 4 and count of I. A2 is B minus C. B2 is just remaining. I mean, I want to here iterate over, I want to say that we take from count of I to the remaining, we move by taking whole triples. So the answer will decrease by count of I minus rem divided by 3. Let's do it this way. Int extra is, so the number count of I, if count of I minus rem modulo 3 is not 0, then continue. Extra is count of I, this becomes ugly, minus rem divided by 3. Now we treat count of I as rem. We iterate like that. B2 will be minimum of 4 and remaining minus C. Here it's me plus C plus extra. Now does it work? It was D. 3. 3, 4. I hope the constant factor is not too big. Roughly speaking, it's 4 times 4, sorry, 5 times 5 times 8, which is already 200. But here the sum of counts will be at most n, so this 7 doesn't matter. Because of that, it's fast enough. Yeah, so it wasn't a hard problem. Still, my implementation is ugly. I will check. This is useful if my implementation is ugly. I like to see what other people, those who solve the problem fast. Here I see that AC in 15 minutes, AC in 21. So he solved it very quickly. Remain, it's not too different. Maybe if this was written slightly easier to, like with more comments or meaningful names, maybe I would try to understand that. Yeah, this chat doesn't work. Can you also do a stream on problems from Project Euler? I'm not very good in maths, so I will not. I think Minimo did it in one day. I don't know about that either. He did some marathon stream solving problems a long time ago, but even the video isn't available, I think. Okay, so now I solve problems up to F. I can read G. If it's nice, then maybe I will try to solve it. Or I will just finish the stream after that, after reading this problem. The tic-tac-toe game is starting on a tree of n vertices. Some vertices are already colored in white, while so it's like the name is tree-tac-toe. Some vertices are already colored in white, while the remaining are uncolored. There are two players, white and black. The players make moves alternatively. The white player starts the game. In his turn, a player must select one uncolored vertex and paint it in his color. The player wins if he paints some path of 3 vertices in his color. In case all vertices are colored and neither player won, the game ends in a draw. Could you please find who will win the game and whether it ends as a draw, assuming both players play optimally? The number of test cases is 50,000. Every tree is up to 500,000. The sum of trees is 500,000. So just we must invent linear or n log n algorithm for a single tree. Some vertices are already white. It looks like a problem that requires a lot of sitting with a piece of paper and analyzing what can happen. If initially there are 2 adjacent white vertices and the tree size is at least 3, then white will win in the first move. Also, if any white vertex has a neighbor that white can paint right now, and then that vertex has a lot of neighbors, then white will win too, because black cannot block him. Also, we can treat... Can black win at all? Is it possible in sample? It is not. I think that the only possibilities are white and draw. I'm not sure. This problem requires a lot of like insight and sitting on this problem. Not really. It won't be much entertaining, so I think I will finish the stream. Also because of the issues with Twitch and chat. I must approve some messages in the chat, by the way. Show. Yeah. So the thing is, if someone in the chat posts a link, I must approve it, so it will be visible for everybody. Yeah, thank you all for watching. Sorry that I messed up, that I spent so much time on D. I thought about dynamic programming and I lacked that one insight. So after seeing the editorial, I understood that in seconds. And it happens from time to time. Nothing to do about it. So if I solved F, I wouldn't be so far away. I guess I would be somewhere around these positions, which is fine. But really, the issue was, oh, people have G here. So with F but without D, I would be still far away. Like what here? Just without the D, it's terrible. And I solved erase. Yes, I did. And then the question is whether I would be able to solve G. So I didn't do well in this contest, but as I said, it happens. I will later also read about H, maybe. What happens here? You're given two integers L and R. Let's call an integer modest if it's in interval from L to R. Find a string of length n consisting of digits, which has the largest possible number of substrings which make a modest integer. Substring having leading zeros are not counted. If there are many answers, find lexicographically smallest one. Okay, so likely we should think about the current suffix of our number, the one with length n, and think whether, like, which suffixes are match prefixes of L and R. Are we in between or not? Just looking at the standings and seeing that this could be a string problem, I know that I wouldn't be able to solve it. I will later give some thought to problem G instead. Looks like just analysis of cases. What happens here? Thanks Rohit and thanks Errichto for the stream. Yeah, thank you for watching. I'm from Assam, living in France. Great. Okay. If you want to like talk more with me, suggest something, you can leave comments below videos, or you can see my Discord and Facebook in the description of the video right here. I think next week on Tuesday maybe I will do some lecture, or maybe on weekend, but that would be the next weekend in a week and a half. I will see and announce as usual in Facebook and Codeforces. Also I have Twitter, but I don't use that often. I just try to put reminders about streams there and videos. So this was stream of Codeforces Global Round 1. Thank you all for watching. Consider liking the video and subscribing to the channel if you haven't yet. And see you next time. Bye bye everybody.